So let's understand two-dimensional matrix and 2D kind of structures like array of pointers and pointer to array. So let me start with a simple matrix program. So if we think of a matrix, we can understand a matrix like this. We can say int matrix max row, some number of rows and some number of columns, right? Maybe you want matrices of different dimension, so we are choosing a max row, just like when we were maintaining a num list, we chose some max numbers. Similarly, this matrix has a capacity of storing max rows and max calls, but actual data stored may be different. Or initially, let me just keep it simple. Let me name it num row and num columns. Okay, I will do that just like that. In the sense that max row and max call means my intent was max row could be 10 and max call could be again 10 possibly, and actual number of rows and column may be different. Maybe you are maintaining 2 cross 3 matrix, but let me not get into that, because to represent that matrix you will need three things: this 2D array and m, value of m, which is number of rows, and value of n, which is not bad. In the num list we did exactly the same thing. We said we'll pass the array and we will pass how many elements are there in it. Similarly, in the matrix you pass the big array, big 2D kind of array, and you pass the both dimensions in the rows dimension and the column dimension. Not bad, but initially I'm just keeping it simple. So I may say num rows is just 3 and num calls is 4, just like that. So I will make it rows. That's fine, and let me write some code. Write 1 2. So 2D structures, when we think how they look like, let's try to draw a picture. So we will use the Google Jamboard in the same manner here. Yeah. So if you have to visualize what is this thing, you can visualize it like this. You can say that it is 3 cross 4. That means there are 3 rows. Okay, 3 rows, and that means there are 4 columns. In this case, that's a matrix. And if I think of matrix, what it is matrix is a name bound here. Please notice that for matrix I did not create a small box having address of something else. If matrix were a double pointer, if it were int star star, I would have created a small box, and I would have maybe created a intermediate small box for single pointer, and I would have finally led to the integer. But just like array is like just a name for this, we understood that for a simple array of one-dimensional integers, we said array is just a name committed here, it remains here. So matrix is also in array only. Okay, and if you see carefully, matrix is a array of arrays. Now this is very interesting. So if you think of what is matrix 0, so matrix 0 is this row, 0th row. So what is this 0th row? It is a single dimensional array of column elements, 4 elements. What is matrix 1? That's this row, and matrix 2, that's this row, and matrix 3 is outside my valid range. I shouldn't say matrix 3 right now, because I will be violating going outside. So you can really treat a 2D array as a 1D array of a 1D array, and even in all your analysis, and when you come to pointer to array also, you can do that. You can intuitively think that when you have a pointer to array and you do ptr++, how much will it jump? It will jump 1 array. because when you have a pointer to int, and if you do ptr plus plus, how much does it jump? One integer. If you have a pointer to struct and you do plus plus, how much? One structure. If you have a pointer to array, then it will jump one array. Although we have not seen how pointer to array looks like, but what I'm trying to say is that my simple logic here is that, let me write here. So I am saying matrix is a 1D array, or I can say array of array, right? Of int. That's right. It's an array of integer. Fine. And and we have seen that array of something and pointer to that thing, they are very much same, right? Array of integer pointer to integer, array of character pointer to character, array of structure pointer to structure, they are quite similar. In the same manner, array of array and pointer to array are quite similar. And if ptr happens to be a pointer to array, and if you do ptr plus plus, it moves one array ahead, and that visualization of moving this array ahead is very powerful. Okay, so we will come to it, but what I'm telling you is that the same principle is applied two times to get 2D array. 2D array is simply an array of something, where something is an array of integer. Okay, and so you apply the same principle two times and you get that. We will see a little bit more. We have not seen pointer to array, so maybe we cannot crystal clear visualize, but when we get to code, we will see. One more thing I would like to say, that that although we draw the matrix like this, we just like it, but actually speaking, the matrix is stored in this manner. The matrix is stored in this manner, that you have the row 1, I will call, and then you have the row 2, and then you have the row 3. So it is called row measure order. Okay, row by row. And again, you can really understand that it is still an array of arrays, because if I think matrix is the array of something, so that something is, it's an array of rows. So this is the element of the first level array, and within that element we have a array of integer. How many integer? In our case, 4 integer. Calls was 4. Okay, how many rows? 3 rows. So it is all contiguous. It's all contiguous. So that's fine. That's good. Now I want to initialize it. Okay, I want to initialize this matrix. So let me initialize it. You can initialize it like this. You can say I have to have 3 rows, and every row has 4 columns. So maybe I will say 10, 11, 12, 13. That's my first row. I will just indent it a little. Okay, that's one row, and I will copy it. I need three of them. Yeah, so my matrix is kind of initialized. Okay, now maybe I can print it. It would be a good idea to print it. So maybe I can have, for a printing a single thing, I need one index. I need 2 indexes here. So I will say for I. So the first loop will be on the first index is the rows and second is column. So I can say I equal to 0, I less than num row, I plus plus, and I'll copy paste, indent, change it. So that's a J, and J goes on the column, and I will print it. I will print the value. I will say print %d. How do I get the ijth element? So I will say matrix ij, and that's fine, more or less, but the indentation would not be proper. I mean, I will get integers one after the other. So let me just, maybe I'll put a space here, and after every row I will put a new line. So that will be like looking good. So I can put a new line after every row. Now it looks reasonably good. So let me try compiling it. Okay, num row and num rows, that thing. Okay, so never mind. Num row, let's see, rows, here I missed the S, here I missed the S. Okay, it gets compiled. I can compile with -WL also, works fine. And let me run it, and I can see that values are printed well, and things are good. Okay, so this is how you initialize matrix, and this is how you do things. Any query? Okay, just like on a 1D array we saw, if there are extra initializers, what happens? If there are less initializers, what happens? So the same thing holds. Let's say, let me have some less initializer in this column, so it will be set to 0. If you have less, remaining things are set to 0. And if you have extra, let's say I have some extra here, and even I can have an extra row also. Okay, so extra row will be discarded. What can we do? Because the dimension is dictated and cemented by this num row and num columns, right? So extra rows have to be discarded, extra column have to be discarded, lesser things, they will be set to 0. So the same fundamental holds. For the extra things we will see some warnings. Now when we compile, it will give some warnings. Even if we don't give -WL, it will give some warnings that excess initializers, they are being discarded. So it caught this extra column, and it caught this extra row also, and it is saying discarded. And when you print it, you see things are good. When we give less initializers, it becomes 0. So that's fine. That's okay. So let's restore it to our clean thing. Okay, good. Now because it is stored in row major order, we can do a peculiar thing. Okay, so I will do that and we'll see. Sorry, CP matrix 1. Because I said that it is row major order, and after all it's all integer, all integer all the way. So you can actually take a int star ptr, position it at the beginning, and you can keep incrementing it, and you can access all the elements. That's what I'm demonstrating now, because it is row major order. So what I will do is I will take a integer pointer, I will say int star ptr, and I will equate it to matrix. I will not say ampersand matrix. I will not say star matrix also. I will just say matrix, because after all my purpose is that this should point here, and matrix is this address. So I will just say matrix. Although compiler will warn here, it will warn us that what are you doing, but we don't pay heed to this warning. We just go ahead. And what we will do here is that we will just keep incrementing this ptr and we will keep printing it. So what, maybe I will write it this way, that I will say I will go num rows into num columns times, and I will just, maybe in fact I can increment the ptr here, why not, that's a nice place to increment it. And I can simply say, it's a quite simple code, %d space, now I'm not delineating between the end of the row and beginning of the next row, but never mind, I'm just saying print ptr star ptr, and that's it. Okay, so let's see if it works. Ideally it should work, because I have num rows into num columns, integers one after the other. I should be able to print it. So of course compiler will warn here, because compiler is right, matrix is a kind of double derivative. You can see it is a int, and then it's a two levels, right? And then on the left hand side it's a one level thing, pointer to int, so they are not really compatible. So compiler will warn. Let's see that. Warning: initialization of int star from incompatible pointer type. In general, be very afraid of such warnings. Whenever compiler says incompatible pointer type, maybe you are mixing int star and char star, or maybe you are mixing double star and single star, or maybe you are doing a single pointer and int. These warnings are very risky, but here we know what we are doing. Here we know that it will work correctly. Okay, so, and also notice this syntax. This syntax is really pointer to array syntax. We will come to it, but this is a pointer to array of 4 integer syntax. Okay, we will come to it, but just pay attention. This is that. We will come to it, don't worry. Let's run it, and we should get the correct output. And we are getting the correct output. The first row, nice one, second row and third row, quite clean. And this is a technique which many algorithms use, because they are stored contiguously and we can use that. It's a guarantee. Any queries? Okay, good. So now let's understand this further. We are trying to basically demystify all the concepts by actually coding. So now let's understand a little more. So we have this. Okay, let me take the previous one, the two-dimensional loop, because that is what we will see more often. We don't see the traversing with a single pointer. We don't see that often. More often than not, you will see the two-dimensional loop. Okay, that's okay. Now let's understand a little more. So what we will do is we will print sizes. We will say what is size of matrix, and in my system it happens to be long decimal, so I will do that. In some other you might be using %d also, it doesn't matter. So I am printing size of matrix, and I will also like to print what is the size of matrix 0, and so I will actually print three things. So I will say size of matrix and size of matrix 0, that means one row. Okay, size of a row, and I will go to the next dimension, which obviously it should be size of int. What else can it be? Matrix 0 0. But I'm just curious. Let's see. And I will maybe comment this output, because I don't want much extra output, so I will comment that I am not interested in values right now. Okay, so we are printing sizes. Let's see. And compiles. So size of matrix is 48. How many? 3 cross 4, right? 3 cross 4 means 12. size of int in my system is 4. So you have 12 into 4, 48. That's the size of matrix. Sounds good. One row which has 4 integers, 4 cross 4, 60. That also sounds good. And this size of int is 4. So that sounds good. As we saw earlier, that size of an array is the entire array. Okay, size of the array is entire array, and we can understand that size of this is this, that also we understand. Okay, so when we pass a single okay, so this is, I think, clear. This is quite intuitive. Any question here? This is quite intuitive.
No, sir.
No question. Okay, so now let's pass a, so with a single dimensional array we investigated that we understand array is a kind of fixed committed pointer, and it cannot move here and there, and size of array is the entire data, not just a address 4 or 8 bytes. Same for 2D array. And when we pass this matrix to a function, then possibly the same thing should hold. Hopefully when we pass matrix to the function, hopefully it becomes just a address. Okay, hopefully it becomes just a address. So we will pass this matrix to a function now, and we will demystify that. Passing one dimensional thing to a function, we know, and we saw that there are 3 ways. If you have an int array, you can pass it like int star, you can pass it like int arr dimension, you can specify, or int arr unspecified dimension. Similarly, let's try to pass this matrix to a function, and in the function we will print it so that we know that it's actually working. So that's the one thing we will do. Let's do that. So matrix 3.c we have, and we will get to matrix 4.c now. Okay, and here we will create a function. Maybe we will call it display underscore matrix. Okay, and we will pass the matrix. So the easiest and the most intuitive way of passing a matrix is you just use the exact same syntax, right, as if you are declaring a 2D array. That's the most intuitive. Okay, let's just make it work with this, and then we will see. Just like for a single a dimensional array, there were 3 variants. Here also we will have the 3 variants, because by now I think you can guess 2D array is a array of something. It's a array of array. Whenever you pass a array, there are 3 ways of passing, whether it's a array of int or array of something else. So the same principle, if you apply, which you understood for array of integer, you can apply the same thing to array of x, and x being another array. So it can happen. So let's see. We will come to that. Let's first get that code there. So I have how many lines? I have 6 lines. So 6 td and t, and I and j are not needed there, but needed here. They can also be moved. Okay, and because I chose the same name, and no harm, they are different scopes, they don't confuse. It looks okay. So let's try to call it and see. So these sizes are demystified, so we don't need it. We will say display matrix, and we will pass matrix. Okay, and matrix 4. Okay, good. And it is displayed. It's all fine. It's all, and maybe at least minus w all we can attempt. Yeah, clean. Looks clean. Okay, so now this is one way to pass it, right? This is one way to pass it. The other way to pass it is Other way is that out of this one dimension I can omit. Which dimension can I omit? Right? You saw that you can like for a pointer to int, when you were passing int array, let's recap that we were passing like this. We could pass like ARR 100, or we could pass like ARR with unspecified dimension, or we could pass like not this, we are saying star. Those were the three variants. Okay, so that's like our earlier understanding from 1D array. Now here, which dimension can I omit? I can omit one of them. Num rows I can omit, or num calls I can omit. So tell me intuitively, which one should I omit, num rows or num calls? So the answer is num rows. Okay, I will explain why it is so. So you can pass it like this. Okay, or you can even say you can even say that you will pass a pointer to array. Okay, now this is becoming interesting, because pointer to array has entered the scene finally. Okay, so now just see array. So array of specified dimension. So this is array of specified dimension, this is array of unspecified dimension, and this is a pointer to int rather. Okay, now what is our matrix? Let's recap that thing. When we said something interesting. We said something that this matrix is a 1D array of 1D array. Okay, so it is a array of this rectangle, right? It is a array of this rectangle. It is a array of something where that something is a array of 4 integer. Okay, can I say that it is a array of something where that something is a array of 3 integer? Not really, because from the contiguous memory you can understand that it's a array of int 4 kind of. You can, I mean, if in intuitive terms you have to write, you can say that it is a array of this is not C, but I am writing in pseudocode. It is an array of 4 length integer arrays. Okay, because that's what when we see the row major order, that's what is happening. 4 length 4 arrays, and it's an array of those arrays. And here also we can see the same thing, that array of this thing. Okay, so can I omit the column? I cannot omit the column, because if I omit the column, when this pointer moves ahead, how will I know how much to move ahead? I need to know how many columns. But do I need to know how many rows are there? I don't care. When I have an int array, do I care how many ints are there? I don't care. All I need to know is the size of one element. Similarly, this little thing, when we say int array 3 4, and we try to think what is array 0 and what is array, okay, array 1. Okay, array 0 is basically these 4 bytes, and array 1 is the next 4 bytes. Okay, so in that sense you can see that array 0 is a array of 4 integer. That's correct. And array 1 is a array of 4 integer, the subsequent. So whose array am I? I am a array of 4 integer. And how many elements I have is not very important. I might have 3, I might have 3000. Okay, this dimension is not very important, but that dimension, that when I do pointer arithmetic ptr plus plus how much I jump, that's important. Okay, so the first dimension you can omit, the other you cannot. In fact, if you have a three-dimensional array, you can omit only the first dimension. Always it is the case, you can omit just the first dimension. Remaining dimensions, they will be there. Is this clear? Anything you want me to say again or something? Yeah, let's see this. So we have a array of specified dimension of arrays. Okay, this is a array of arrays where I have specified the dimension. This is a array of arrays where I have not specified the dimension, and this is a pointer to array. And of course, I mean, there is no question of specifying a dimension. So you can really understand that this goes parallel to int star, this goes parallel to unspecified, and this goes parallel here. So this is what it is, and I'm sure from the earlier text you would remember possibly rows can be omitted, but this thing might be new to you, that you can have this pointer to array, okay, pointer to array, and pointer to which array? Pointer to this array of 4 elements, array of columns elements. You cannot visualize a row element, that doesn't make sense because the storage is like that. So that's good. And I earlier said that size of matrix, if we print in the main, it comes to be 48. When I print it in the function, it should come 4 or 8 bytes. The answer is it will come 4 or 8 bytes, because when you pass matrix, then the matrix degenerates to a pointer. When you pass a int array, like you pass a int array, that kind of, even if you use this syntax, that this ARR is a pointer to int. Similarly, when you pass a 2D matrix, that matrix is a pointer to an array, because 2D matrix is an array of array. So when you pass an array of something, it becomes pointer to that thing. So 2D matrix is array of array, and it becomes pointer to array. So this exactly the matrix, if you certain inside the function, it behaves like a pointer to array. For now, let me just print the size of, and we will see it, why it behaves pointer to an array and how does it matter. We will see, but first let me print the size of matrix. Okay, that's crucial. Is it 48 or is it 8 bytes? In my system it is 8 bytes for pointer. So I'm saying size of matrix percent. So let's see, matrix, and so matrix 4, and we, whichever way we pass, it doesn't matter, all are the same in effect. So let me compile. Sorry, I forgot that size of thing. Okay, so it is 8. Okay, now I will do one more thing. So one thing we agree, that when we pass a matrix to a function, it degenerates to a pointer, but it's a pointer to what? It's a pointer to one row, kind of. One row is 1D array of column integers, so it's a pointer to one row. So let's prove that point. Let's print the value. So I will say print matrix equal to %p, it's a pointer, and I will say that's it, print the value, and then I will increment, because if it is a pointer to a row and I increment it, it should jump one row, because pointer to int jumps one int, pointer to double jumps one double, pointer to structure jumps one structure. So pointer to array should jump one array of 4 integers. So with that understanding, I will do matrix plus plus. I can happily do matrix plus plus here because here the matrix is not a array. If I do this matrix plus plus in the main, compiler will give an error because it's an array. How can you increment it? But the moment you pass it to a function, it's no more an array. So I will increment it. I will obviously comment this code because after incrementing I cannot afford to print it this way. So I will increment it and I will print like this after increment. Okay, so okay, let's see. So if it is jumping 4 integers, one row, so 4 into 4, 16 bytes. That is the difference we should see. And let's see. Variables are unused. Warnings for now ignoring. And you can see that it was FFC0 and now it is FFD0. That means it's hexadecimal, right? So you have added 0x10 C to D. 0x10 is 16. So it is proved that when you pass a matrix, what you are holding in your hand, even if you declare it like this, but it's not a 2D array, it is a pointer to array. Okay, and pointers to arrays are that simple. They are nothing big. They are pointer to something, and pointers have that nature. When you increment, they increment size of that thing, so it increments size of that array. So like that. Okay, so now we have understood pointer to array, and pointer to array syntax is not difficult. Just pay attention. Just pay attention. Let me copy this thing here in the notepad. So this is pointer to array. That's fine. If we just imagine what is an array, okay, that's quite easy. Array is like this. Array. Now we want that a pointer to such an array, a pointer to something such an array. That means instead of this array, we are saying the star PTR is that array. Okay, so you can think of it that way. It's not an expression which we are calculating, but one way of thinking, you can say that star PTR and bracketized is the array. So PTR is pointer to the array. Be very careful that when you don't put the brackets and you write like this, this is not a pointer to array. This is a array of pointers. Okay, so maybe you can understand it this way, that let's just check you can understand that this array has more precedence or something like that. Maybe we can check that precedence table, but this is a array of num calls pointers. So these, and this is a pointer to array. Please be very, very careful about it. This is not a pointer to array. So you can in a way understand that that this takes kind of more priority. So PTR becomes a array of int star in line number 7, and here star PTR is an array. So PTR is, because star PTR is an array of 4 integers or num calls integers, so PTR is a pointer to such an array, array having 4 integers. So this is how you have to visualize and just differentiate these two. So I think we got some idea of matrix and how it relates with pointer to array. It relates to pointer to array whenever we pass it to a function. It becomes literally a pointer to array, and array of pointers is something totally different, and you can use the array of pointers in a matrix. If let's say you have a symmetric matrix and you want to store only half of it, maybe because it's a huge matrix, or maybe you have sparse matrix, you want to maintain linked list, like which nodes are present, you can have array of pointers. So we will see that. First, before that, see let's just see a little what is left, kind of. And so pointer, how to pass, we have seen. We will see a little more things maybe in the next session.